I'm saying solve for x. How do you solve for x?
You have to bring on the other side.
Okay. I would get x by itself, which means I'd have to move the other stuff to the other side, which it would become then negative 5 plus 5i. So now, how do you get rid of the cube? You would normally don't write the cube root because this is not going to be right. How do you figure out what the cube root of negative 5 plus 5i is? You really don't know. You're right. You really don't know. And actually, how many answers are there?
A lot. Unlimited.
If it's x cubed, how many solutions are there to the problem? There's 3. Okay. I'm sorry, I was taking my time. I wasn't sure I turned it back on. If it was x to the 7, there are 7 answers. Okay. If I give you a nice number, if I gave you guys x cubed equals 8, what are you going to tell me the answer is? 2. You're going to tell me the answer is 2. But there really are 3 answers. Why haven't we ever found the other answers? It would only if we cube root it, we would just get 2. The other 2 answers are complex numbers. We've never been able to find them before.
And we never will.
We can now because we can do it polar form. We can find all the answers. So we're actually, but instead of doing cube roots, we want to learn. Oh, I'm taking that away. Darn it, I didn't want to take that away. Never mind. I'll just erase it. I don't want to do it as a cube root. What's another way to write a cube root, but not write it as a root? There's a power that will get rid of x cubed. Close. 1. Yes, it would be a 1/3 power. Okay, because now why would I rather do this as an exponent? Because I know this theorem, and I can use this rule for taking it to a power. So I want to do this as an exponent so I can use this rule again. Okay, but your problem is that means you're taking this expression to the 1/3 power. Oh, thank you. I did. Excellent. Okay, yes, I did have a negative 5 there originally. Okay, so you're actually going to take this, what you're trying to do is you're trying to take this complex number to the 1/3 power. So we have to do the Laplace theorem here that we just did, but we have to take it to the 1/3 power. Because I moved it to the other side of this equal sign, so I had to change. Okay, so you have to get this into, first of all, into polar form. So you got to change it to polar form. And you're going to take it to the power using de Moivre's theorem. I'm not going to be able to break my old habit of how to count that now. So that's our first 2 steps. This one you should be going, oh, it's going to be an easy one to change forms to. Negative 5 would be left 5, up 5. You all should instantly be screaming at me what the reference angle is. They're both 5.
45.
It's a 45. So we know that's a 45. But it's in the second quadrant, so it's really 135 degrees. Yes. Okay. The other, I need R. And actually, if you remember your special right triangles, you know what R is going to come out to be too. Not 15. Well, Pythagorean theorem is going to be 25 plus 25 equals R squared. That's 25 times 2. 5 square root of 2. And if you remember, you learned in geometry, you take the leg times square root of 2 to get the hypotenuse when it's a 45-45 right triangle. So, yeah, it's just 5 square root of 2. So I'm going to have, except I just used up my space. Yes, you could have done that faster with geometry. I would recommend the geometry if you know the geometry. Okay, so the point was I wanted to get it in polar form. So I now know R is 5 square root of 2, and I know that my angle is 135. Okay, here's where it gets interesting. Cody, move. You have no books out, no notes taken. Down here. You got to learn how to do this. This problem is worth like 12 points on the quest. Because how many answers am I going to get to this problem? If we're doing cubes, we're going to get 3 answers. If I give you an x to the 5th power, you're going to get 5 answers. If I give you x to the 8th power, you're going to get 8 answers.
You're horrible. Right. Horrible.
Okay. So my goal in this case, remember, I was doing a 1/3 power here. Okay. So, I did a terrible thing.
What did you do?
That's what I get for changing my numbers. Okay. No,
It's not going to work out right.
No, it's gonna. This is gonna be a horrible number. I have to take 5 square root of 2 to the 1/3 power. I wouldn't be that evil to you. But I don't want decimals, but we may have to settle for decimals on this one. I wouldn't be this evil to you. I don't think. No, I don't.
Okay, continue on.
Okay, well, actually, you do run into this on one problem. You wouldn't want to do this then, since neither one will go evenly to the 1/3 power. The easiest way then would go back. That was square root of 50 to start with. Square root of 50 was 5 square root of 2?
Yeah, but you're about to do hardcore.
Okay. So, I'm not going to go, nah, this is not hardcore. If it's a square root, how do you take a square root to the 1/3 power? Because you do have one of these somewhere, I know you do. Okay, would you agree that square root is a 1/2 power?
Yeah.
Yeah.
And I'm taking it to the 1/3 power?
Yeah.
So what do I get?
I don't know.
I get the 1/6 power. I simply multiply them together. You knew that from algebra. You really did. So you can just leave it as 50 to the 1/6 power. It's fine that way. What do I do to the angle? What did you do back here with the 4? We times it and got 280.
So you multiply by 1/3?
So here, I'm going to take 1/3 times 135, which is 45. Okay. Now, most of the problems I'm nice, and I say to you, may leave your answer in polar form.
This one you're not going to let.
Actually, this one I am, because of time-wise, I'm going to let you leave it. Although converting cosine of 45 back to the other would be no big deal. Put in your square root of 2 over 2s, but we're fine. We'll leave it as 1. Problem is, that's only one answer.
The other one.
How many more do I need?
2. You're going to need
I need 2 more. Okay. I'm once again, for a moment, going to show you why this happens, but then you're going to see the shortcut once we get the answers. Okay. How can I get other answers? I've done this once. How could I do it again? Well, is 135 the only angle that ends up in the second quadrant at this location?
You have to go around like plus 360, plus 360, plus 360.
If I went around a 360, wouldn't I get the same thing, except if I add 360 onto this, that would be 495. And so I could do it again. You aren't actually going to have to write this all out once we find the shortcut here in a second. And then you would do it again. Take it to the 1/3 power. So the 50 is still going to come out to the 1/6. What angle are you going to get this time? 1/3 times 495 is 165. So you would get this time cosine of 165 plus I sine 165. Okay. And then, how am I going to get another answer? I would add another 360 and do it again, which is going to be 855. Okay. Well, if it's x cubed, I'm supposed to get 3 answers. I've got 2 answers. I need my 3rd answer. Okay. But there's going to be a shortcut here in a second. So if that's 855, what's going to end up over here? How do I figure out what angle that's going to be? 855 divided by 3, because you're going to take 1/3 times 855. Thank you.
Yeah, I think it's
Yes.
Why is it that number?
Well, Devin just said why it's that number, that's where I wrote. Yeah, cause you added 360 and you're taking a third of it. So you're just adding 120.
You take that thing and add 120.
So if this was 1/4 power, 360 times 1/4 would be 90, so you would just add 90 to every answer. You have to do the first answer, and then you can figure out how much to add to get all the others. So if it's a 1/6, you would add 60 to every answer. Okay, notice, the answers always come out less than 360. When you get done, all of your answers will be under 360. If you keep going, it just starts to repeat itself. You get angles that would be the same as 45, next it just repeats itself again and again. So you really like to figure it once and then just add on.
Go, Jim, go.